might have to make 3 clips here. We kind of got cut off there somehow. But we're making 40 passes to get this 1'8" left-handed thread done. Making nice clean cuts, and then we're gonna measure the thread. You know which pass we're on? How many we've got left to do?
I think your finishes are like 8:46 or something like that, so we gotta wait.
Okay, so we're on our control here. We got to go down to 846 or 876. So you can see what the diameter is that it's going to. 874. So it's going 2,000s deep per pass. So that's 2,000s per side or 2,000s on the diameter. On the diameter. So we're only going in 1,000th at a time on the tool, and that gives it a chance to make a nice clean cut as it's going through the cut there.
As it goes in though, it goes 29.5 degrees the tool feeds in at. So instead of plunging straight in and it's cutting on both sides of the insert, it plunges in. So this is 60 degrees, the thread angle. This moves in at half that. So as it feeds in, it's only cutting on one side of the tool.
Okay.
So it's less stress on the machine, tool. It makes your tool life last longer. You can have it on the more, fancy machines. You can have it cut on one side of the thread on one pass, and then the next one have it cut on the other side of the insert, just to prolong your tool life.
So you're saying this goes in at 29 degrees?
Yeah, 29.5.
29.5 degrees. So typically, this thread is a 60-degree included angle. So if he's got 29.5 degrees on his feed into the cut, that means that the one side of the thread is at 30 degrees. Your tool is moving in at 29.5 degrees. So you've got what on the side of the tool? You've got clearance on the side of the tool. You're not rubbing and engaging the entire tool bit, the surface around the V. You're only cutting on one side, so that's an interesting observation there. I believe, now you might be done. Let's doing a couple of cleanup passes there. And now we can, did that shut off by itself?
Nah, shut it off.
Okay, Dan's going to measure these threads here. So here's where you got to hold your tongue just right when you measure stuff. You've got to take this chart here. Go ahead, Dan. You can explain if you can read upside down.
Yeah. So it's 8. So we got threads per inch. It's 8. So we got the 72 thousandths diameter wires, and then you go to the add column here. So we got 26 thousandths. So we add that 26 thousandths.
265 and a half.
Yeah. We add that to our major diameter, which in this case will be 1 inch. So when we use our micrometer to measure this, we should get 1 inch, 26.
265 and 6.
Yeah, what's 26 thousandths?
Okay. All right. So let's give it a shot there. Yeah, it's 265.
Okay.
So it's going to be 1 inch, 265. So let's get over here and see exactly what Dan's doing here.
So,
would you like me to throw a rag underneath there in case you drop one of those pins so you don't lose it? I know it's long and straight compared to one of the stringy chips here. I'll get out of your way if I can here. But you hold the oops, I dropped the rag. Put this under here because oftentimes you got to try it about 3 times before you can get your measurement good there. Okay, that should be good. So he's got the micrometer holding the two on top of the 2 rods, if you can see. And now he's going to slide the other wire underneath between those 2 rods to the bottom on the vise anvil, or the micrometer anvil. And now he can come down and measure. He's equally over the top of the threaded cut there. He's got the 3 rods he's miking over. And what kind of reading you got there? Look at that.
1 inch, 25.5 thousandths.
1 inch, 25.5 thousandths. What are we looking for?
26 and a half.
26 and a half. So it looks like you're right on there.
Yep.
Nice job.
Yeah.
So we'll take all this stuff off and try not to lose our measuring wires. and put that back over here.
Thread the piece on.
Oh, you want to try that too? The acid test is to see if the
Yeah.
part fits. Let's try that. You sure you got the left-handed
I got
thread on
it
there?
the right way.
Yeah, lefty, tighty, righty, loosey, or
Yeah, something
righty,
like that.
righty, tighty, lefty, loosey. Look at that. That's going right in there.
Yeah. Might need another pass or
Yeah,
something.
it's a little bit
tight.
snug. Now, did you run a tap through that that nut there?
Yeah, right.
Okay, because you get into bigger threads, you can single point the internal threads, but this is small enough where you have an awful hard time cutting a coarse thread like that in a small hole.
Yeah.
So you use a tap like that. So he's got a left-handed thread on one end. You can see it's left hand on this side and right hand on the other side. You can kind of see the writing on there. So obviously you get the two pieces together. I don't know how far the threads go past center, but you've got a good fit in there. So you can take that thing back out of there. We're talking about single pointing some parts here. I'm going to digress here for 1 second. We've got some flanges that we're making here in another machine. And what we do, we bought some burnouts. These are burnouts here. Get them laser cut or plasma cut or however we do it. Then we made a fixture here on in the lathe. Put this thing up in here. Clamp the burnout in place, and then we bore the ID of this with our boring bar up there, and then we've got our internal threading tool, and then this machine also happens to have live tooling in it, and while this is in the fixture, if I can get it in there, I'm not able to get it in there real easy, we can actually go over and drill and tap these two holes while it's still in the lathe from when we cut this internal thread here. This is a lathe with live tooling, which has the capabilities you can see here. There's a tap, there's our drill, there's our spotting drill back there that will go in and start the point for where the drill's got to go. It drills through and then it taps. But you got to stop and think, threading this internal hole here is done as a lathe operation, but to tap these while it's still in the fixture in the lathe, the machine then changes mode and the chuck is held in a stationary spot, and then the tooling on the turret, this is live tooling, this tap turns, there's a attachment on the back here where this drill turns and the spotting drill turns. So you can go and offset, and the chuck moves 180 degrees, 2 different points, and you can drill and tap the holes in there. So we're not talking about basic machining here. We're talking about CNC multi-axis cutting. Here we've got thread gauges that we use to go and a no-go gauge for this thread that we cut in here. It's a 4-inch NPSM thread or something like that. It's a straight pipe thread. Anyhow, we've got a pile of these things to do, so we'll go back over here by Dan. He's got his turnbuckle over here. He's made that. Did you make your other cuts there yet on that, or not? Okay. The last operation we do on these pins that we've made here is we have to take these over the milling machine and mill a flat on here and put a cross hole in for the pin that attaches these left and right hand thread pieces onto the clutch mechanism on the steam engine.
They're wooden shoes that on the flywheel presses on the inside of the flywheel, and there's wooden shoes in there. So over time they'll wear out. So that's why you have the turnbuckle, so you can constantly adjust it. And if you're doing heavy pulling, they sometimes could slip. The flywheel will actually spin over the clutch, and you're not going to go nowhere, so you might have to adjust them out a little bit more.
And there's two clutch mechanisms in the flywheel. They're opposite sides.
180 degrees apart from each other.
Yeah, okay. So anyhow, we've got a nice example here of some machine parts that hopefully you can kind of catch the idea of what they're used as and what they're used for and how the application is. 100 years ago they used these things, and today they still use turnbuckles like this. So just an interesting little display of how machining is done. I apologize for not having a manual machine to do this in, but Dan's got this thing set up, and he's got it at his disposal to do the machining, so that's what we're doing. So Dan, I'm going to bid you a cheery adieu here, and Maker's Machining will be back again with more stories. I think we're going to have these 2 clips here that we did, and then I will post a video of the steam engine with Dan driving there. Dan's got big arms because the steering is not power steering on those steam engines there. You know, he gets a workout every time he drives that thing. So we've got a nice little clip going. So anyhow, back to the channel, and we'll get this all set up for you. Thanks for joining us today. So long.